Hello, this is Venkatesan working as a working as assistant professor at St. Martin's Engineering College. So today we are going to see about introduction to the machine learning. First of all, we are going to see what is machine and what is learning. Right. So first we are going for what is machine. So why we have created the machine means to reduce the work of the people so that it makes the work very easier to complete. So that is known as a machine. Next, the second thing we are going to see here is about the learning. So learning means we know that it is a process of gaining knowledge and skills by studying or being taught or when we have experienced something. Right, that is learning. So the next one is we are going to see the definition of the machine learning according to the Tom Mitchell. So here what happens means the machine learning is the study of algorithm, right? So which improve the performance P at some task with the experience E. For example, we can take the best example for this one. We can take driving a robot is driving a car. So first we are going to see about the performance. So what will be the performance if the robot is driving the car means the performance is without any disturbance it should reach the destination to source to destination. So what are the tasks we are going to perform in that means we should drive the car on the highway. So the next things with the experience we can say with the experience that how while riding the car in the road on the road we can see that what are the experience that is we will see the images, we will see the other vehicles. These are the experience we can get from them. So the machine learning, the explanation goes like this, that is, it is automatic learned from data which will improve the performance and from the experience and predict the things without being explicitly programmed. So this is known as a machine learning. Next, we are going to see about here what is the traditional programming and the machine learning. So in the traditional program like C++ and Java, what we will be doing? We will be giving the input, right? And at the same time, we will give the program and we will be trying in the traditional method we will give these both and we will get the output. But in machine learning what happens means we are going to give the input also at the same time we are going to give output also in this so that we will get the output as a program. In previous tradition we will get the output but here we will get the program. This is the method we are going to follow in the machine learning. So next we will see about the machine learning. So if you see the example here means actually you can see they are given the input as a car. So in the machine learning what it will do, if you see this, if you are given this picture, right, it will show whether it is a car or not a car, right or not. So like this only the machine learning will work in the image classification, right or not. So here we can go for the decision tree also. Here you can see the decision tree, right. So here weather, time, hungry, bus, these are the nodes we are given, right or not. Here what happens means, so from this you can take the decision easily. Suppose if it is sun, if you want to walk now, you have to see the time, then you can walk. Suppose if you are hungry, at that time, if there is no bus, you can't be able to walk. So these are the decision tree with the nodes, it will follow. So next thing, so here you can see the clear difference between the machine learning and the deep learning. So here what happened, in the machine learning, we are going for input as a car and we are having the feature extraction, right. The next thing it will go for the classification. Next the output it will show that whether it is a car or not a car. But here what happens means, here we are going to take the same picture in the deep learning. So here what happens means, here you are going to give the same input as a car here. Then what happens, here you will be having the multiple neurons. See here, the feature extraction plus classification, you will be having more number of hidden layer in this. And actually what will be the output? The output will be what is the color of the car, what is the make and what is the model, so everything it will be showing. So this is the main difference between the machine learning and the deep learning, right. So next, so why we are going for the machine learning is, so machine learning you know that it is a subset of artificial intelligence, right. Here what happens means which allows the software applications to predict more accurately the outcomes without explicitly programmed. Next point, it uses the historical data as input to predict the new output values. So for this, you can take the example of weather prediction itself or the stock market, right? So in the weather predictions, the previous year, 100 years data you will be having. If you are going to give this as an input, right, it will show that what is the weather condition that is tomorrow it going to happen, right? At the same time, I told the second example as a stock market, right? If you are in the stock market, you will be having the 50 years stock market historical data. If you are going to give to the machine learning means, it will predict what is the next outcome, the value it is going to come, right? These are the best example we can say for the historical data. The third one is it uses a recommendation engine also, right? And the fourth point, Max, it is used for like including the fraud detection, that is who is making frauds and spam filtering. So we can go for spam filtering, that is in the emails we will be getting the spam mails, that also we can find easily by using the machine learning algorithms. And we can also able to find out the malware threat detection also. And then for other applications like business process automation also and predictive maintenance also, right? Next, you can see that why we should use a machine learning. Actually, why we are going for machine learning means here we can use large number of data sets, right? Large number of data sets, and we can use large number of variable to get that output without the existing formula or equations. Again, here they are given some of the examples. So here we can see that first the written is handwriting written rules. So we know that handwriting regularization problem, right? So next thing, they can use it for the fraud detection. In the previous slide, we have seen that what's the use of the fraud detection, right? How it will be used. Next thing we are going for, that is forecasting and predicting the market, right or not. So suppose the best example we can say that we are going to purchase a mobile in the Amazon, right? So when we are going to again log into the Amazon app, again it will show that what are the product accessories you are having. For example, if you are going for mobile means it will show the what are the accessories you want to purchase. Again, if you are closing the tab, again if you are opening once again means what happens means again it will show the historical, the mobiles whatever you have searched, the same thing it will show, and what are the other mobiles mobiles it is there with the same rate it will show. So these are the machine learning algorithm we are used to show them, right? Next, we are going for the most important topic is types of machine learning. So here it is categorized into 4 types. One is supervised learning, unsupervised learning, reinforcement learning. So we will see what is supervised learning. So we know that the supervised learning is nothing but which will be having the labeled data, which means the data is tagged with correct labels. So for example, we have seen the previous example that we are going to find out whether it is spam, mail or not. So another thing, it is used in the supervised learning. Here we are going to test our model by testing with some data sets. After that we are going for the training data sets, right? So this is a best example we can say for the supervised learning. So what is mean by labeled data? Labeled data means nothing but you are going to train the data with the label, right? So that you can find out predict the output. For example, here we can see that, so already we have trained the machine with the labeled data. We are seeing the square, triangle, hexagon picture, right or not? Already we are trained with the labeled data in the supervised in the machine model itself. So now what we are going to do? Now we are going to give the new labels. So here we are going to give the 2, 3 labels here. Now what the machine is going to do means it is going to predict what is it. So what happened? This will send to the model training. Again it is the tested data already it will be present. Now it is going to predict. So you are given your 3, so it will predict the square and triangle correctly. So you have to note it down that in supervised learning, you have to train the machine with the label data before itself. Then only it can able to predict the data accurately. So this example will be clear. Next, here the supervised learning, they are given the same thing. In the previous slide we have seen the triangle, square, but here what happens, they are given the two images. One is apple and orange. With this apple and orange we are going to try the machines, right? After that, if you give the apple, what it will say? If you show the apple picture, means it says that it is an apple. So here, before you are going to predict the model, these are the inputs you are going to give. The first input is you are going to give the training test documents, like images you can give the sounds also. These are the labels you are going to give. So next process you will move to the feature vector. Next it will go to the machine learning algorithm. After it move to the predictive model, and it will go for the expected label. Like this only the supervised learning will work. So here we are going to see what are the types of supervised learning algorithm. We are seeing what is the supervised learning. I told already that the supervised learning is which will contain only the labeled data. Now we are going to see about types of supervised learning. In the types of supervised learning, we will be having two types. One is classification and regression. So what happened here is, in the classification, the important thing you have to note out is it will categorize the data. For example, the classification we can say that for true or false, or the color not a color or not, apple or not apple or not. Like that example we can take for classification. What about the regression problem? We can say the best example of predicting weather, right? So in that we will be having the variables which is having the real value, right? So this is a classification example and regression example. So we are going to see about the supervised learning example, right? So here what we are going to see here means, here they are given the 3 months baby. If we take the example now, we are going to train the baby, right or not, to show how the apple is. So if you want to show how the apple is means, first you have to show, you have to say about the features. So what are the apple features? You can say the example is color, shape and size. If you say these features, then only the baby can identify that it is an apple or not. Like that, you are going to train the machines with these features in the training data sets, so that if you show again means it will say that, suppose if you are showing the picture apple and orange, it will say whether it is apple or not. So next we are going for classification. As I told that classification means it is going to categorize the data. So the best example we can see here BP of the patients, right, blood pressure. So we are going to see the classification how it works. For example, we can take the patient is having 98. We can say that he is not having the heart attack. Suppose if this is having the BP out of 190, if he is having means, we can say that he is going to get the heart attack. Like that we are going to classify here, right? So classification means we can say categorize. Categorize means whether yes or no, true or false, 0 or 1. Like that we are going to categorize. Next we are going for regressions. So regression, I told that we will be using the real values, that is prediction. So here what we are going to give means, in this picture you can see that 3 chocolates they are given, right or not? So one chocolate costs 50 rupees. So what is the cost of the 3 chocolates? So it will be 150. Like that we are going to train the machines with the labeled data. For example, we can say the historical data of our weather predictions, right or not? So past 50 years data if you are going to give in the regression model means, it will say that what will be the correct weather of the next day, right? So next we are going to see about the unsupervised learning. I already told that the supervised learning means that is labeled data. So unsupervised learning means that is unlabeled data or uncategorized data. So in this we won't give any labeled data, right or not? Directly we are going to provide the picture, and here we are not going to train the data also with the machine, right or not? In supervised learning we are going to train the machines with the labeled data. Here we are not going to train the data with this. So here you can see the picture here. So here they are given the label as this picture. So what the unsupervised learning algorithm and the machine will do means it will segregate the duck separately and the rabbit or rat separately. Right. So what are the types of unsupervised learning? So the types of unsupervised learning is clustering in association. So as you know, what is a clustering? So clustering is used to grouping of data. So grouping of data means suppose if you are giving the animals. So what happens? It will say that it will group together. These are the elephants. These are the rabbits. Right. In the picture, it is going to segregate and it will show. It will group the objects. Right. So in the association rule, so it is want to discover the new rule that describes the large portions of your data, such as people X also tend to buy Y. For example, we can take this association rule meaning that suppose if your people they are going to buy the milk, what is the next thing they are going to buy? So the next thing it will be a biscuits or the tea powder or the coffee powder they are going to purchase. So another example we can say that suppose if they are going to purchase one new mobile. So the next thing, what are the accessories? For example, if they are going to purchase mobile phone, so they are going to purchase the temper glass or the headsets. That are the accessory it is going to come. So in that it will frame the association rule. Like that only it works. Next, the reinforcement learning. The reinforcement learning we can say the best example is driverless car. So what happens? The driverless cars, the agent will interact with the environment, right? According to that, it will work. So we can give here penalties, right or not? For example, if you are discovering a new game, right? If they want to win in the game, you are going to give them rewards. So if they get more rewards, they are going to win the game. Suppose you are going to give them penalty also. So penalty means if they are getting the low penalty, they are going to lose in the game. So like that thing you are going to set in the reinforcement learning algorithm. So next thing is these are the supervised and unsupervised algorithm we are going to use. The first one is regression. Second thing is decision tree. Third thing is random forest. So in the decision tree we are going to use an algorithm like ID3, CART algorithm. So random forest you will be using multiple decision tree. From that we are going to take the best fit. That is average. We are going to take in the classification algorithm we are going to use k-nearest neighbor and logistic regression. So in naive bias, so the naive bias will be using the conditional probability and the SVM is support vector mission. We are going to classify the hard margin and the soft margin in them. So next in unsupervised learning we are going to use clustering. In that we are going to use SVD, PCA and K-means. Next in association analysis we are going to use APAP and FP growth and intent marker model. So these are the supervised and unsupervised algorithm we are going to see. Next, the main thing we are going to focus on next one is what is difference between AI, machine learning and the deep learning. We know that the AI, that is artificial intelligence, which can, it is a technique like to mimic the human intelligence using the if-then rules. So what is the machine learning? The machine learning is a subset of AI which enables a machine to improve the task with their experience. So next we are going to see about the deep learning. Deep learning is a subset of machine learning and the AI. But here what is the thing now? You are going to perform more tasks in this like speech and image recognition. So for example, if I want to say means we can say that suppose in the machine learning we are going to use 100 data sets. In the deep learning we can use lots of data sets. Right. These are the main difference. That only they kept here. We are going to use a vast amount of data. Right. At the same time, if you are using 10 hidden layers means in the deep learning you are going to use more than 200 hidden layers. Like that it expands. These are the difference between AI, ML and DL also. The best example they are given is online shopping. I told about the online shopping, right? Once we have purchased an online shopping, again it will show the what are the histories. From the histories it will take the survey and will say that what is the next thing you are going to purchase or next thing you want to purchase. So these are the types of artificial intelligence that is now currently is going on. We are going to see only these parts, that is narrow or weak AI, general or strong AI and super intelligent AI. So first we are going to see about narrow or weak AI. So example, we can say that it performs a narrow task. So we can say here facial recognition and internet search. So general and strong AI. These are the next important topic now it is going on. Right? So here in the strong AI, nowadays we can see that the human robots, right? Like human beings, how it is going to give the reactions in the eyes and the mouth. It is like human itself, right? It will work like that. So the super intelligence AI is, it will come within the next 5 to 10 years. So it will be the super intelligence AI will be, that is, it will work beyond the human being. That is how the research scientists are doing. Like that it will work. The super intelligent AI. So next topic we are going to see about the perceptron. Perceptron general form. So how the perceptron will be means, first we will be having the input layer. So the first we can take as x1 and second one we can take as x2 and the third one we can take as x3. Again, these things are connected to the another node, right, which we can say as a summation, right. So here with this it will be added with the bias. So here you will be having the weights W1, W2 and then W3. So this node will contain the formula as, that is summation of Wi into Xi. Again given to the activation function, right, that is G of X, and this will be the activation function. Again we will be giving to the output layer, that is Y cap. So this one we can say as a output layer. So the formula will be there. So you have to find out the output, that is Y cap equal to W X plus bias. So here what happens? R x1 will go to the node, that is summation, that is x2, x3, and here we are giving the weight, and we are going to add out the bias value with that, and it will go to the activation function, and the output layer will be Y cap. So the Y cap formula will be W, that is input into weight plus bias. So this is a perceptron general form. So we will take one example in this itself. We are going to find out how that output layer, that Y cap will come. So for example, x1 equal to 2 we can take here. Then x2 equal to we can take 1. And x3 also we can take it as 1. So now we are going to give the weights. So weight means, so we are going to give, for example, 0.2. So here what happened? We are going to give 0.1. Right. Here again we are going to give 0.1. So it will go to the node. I told that it will contain the summation, that is Wi into Xi. So for example, here what happened? First we are going with the X and W1. So what happened here? So X1 W1, which is equal to, what is the X value we are given first? 2 into, what is the weight we are given? 0.2. So you will get 0.4. Next, the X2 into W2. So you are given 1 into 0.1, which will give 0.1. Again, X3 plus W3, which is equal to 1 into 0.1, you will get 0.1. So what is the total value you will be getting now? If you add these three means, you will get 0.6. So your answer will be, the output layer you will get as, that is Y cap equal to, right, W, that is so 0.6 plus bias value. So here this weight value you are going to enter. So here you can ask what is the use of the weights. So what is the use of weight means it is used to strengthen the particular node. It is used to strengthen the particular node. So what you can say how we are going to strengthen the particular node. So here what happens means we are not going to represent any weights. We are not going to represent any weights. Here the machine will automatically will be updating the weights. Like for example, if the patient is having the heart attack, right? So if you take the example of BP, right or not? So we can select the one layer that we can increase the weight so that it will become the strength of the particular node, so that we can get the whether the person will get heart attack or not. Like that it goes on. So this is the perceptron general form. Like this only each and everything it works. The perceptron we can say as a single layer perceptron also is there, and multi-layer perceptron is also there. So single layer perceptron means, so you can see here. So this is only one hidden layer will be there, right? So we can see here, this is a hidden layer, this is a input layer, and this is the output layer. This is a single perceptron. So if you are going for multiple perceptron means you will be having multiple hidden layers, right? So you can see here multiple hidden layers it is present here. So this is a multiple hidden layers. It will contain the multiple hidden layers. That is known as a multiple perceptron. So last thing we are going to see about the sample video, right? How it So here we can see that how it is going to perform the thing without explicitly programmed. So we are going to give the data and how it is going to find out the accurately. So the machine learning artificial was found by Arthur Samuel in 1959. So here they are given the game from. So here they are given some applications. You can see here, right? The person whether it is taking, it is showing whether kite or not. Here classification problem. You can see this is used for predictions. So prediction means you can predict the temperature values, right? Next accurate data, right? So if you are giving that CSV file with the data sets, you are going to predict the accurate values. Next, that only they given us. So here you are going to give all the data sets, right? Next it is going to use the feature engineering. Features means what type of features you are going to give in this, right? Next we are going for training and test set. So in the training we are going to give 75%, right? In the test we are going to give 30%, right? Next algorithms. So we will be using the Python, right? Python and this one. So the last thing we are going to discuss about is what are the different types of model we are having the machine learning. The first thing is data collection. So in the data collection we are going to collect only the accurate data which is related to that, and next we are going for data preparation. In the data preparation we are going to remove the unwanted data, noisy data or irregular data which is there, and in the training test distribution we are going to give how much data for the training and how much data we are going to give for testing, and then choose a model. In this we are going to choose which algorithm we are going to train the model with which algorithm. So here train the model. So we are having different algorithms. With that model we are going to train. After that we are going to evaluate that model. The last we are going for the hyperparameter tuning. In that you will be using the prediction. Example of prediction we can use in this. So here from the beginning we have seen. So here I am going to conclude the classes. So the first topic we have seen is what is the definition of machine learning. Second thing we have seen about the supervised learning. So what is supervised learning? That is a labeled data. We have seen about types of supervised learning. After that we have seen about unsupervised learning. In that we have seen about what are the types of unsupervised learning. That is clustering and association, right? After that we have seen how would the clustering works. Clustering means it is a grouping of data. Association means it is going to derive the new rule, right? And we have seen the example how it works, right? And we have seen the what are the applications of machine learning, right? The application of machine learning, we can say that it is used in the speech recognition, fraud detection, right? And we are going to predict the weather report. In the prediction also we can use. The future enhancement will be that the machine, without the machine learning it is very difficult. So the more applications whatever we are using in the future, it will depends mostly on machine learning and the deep learning. So that's it. So we have seen how the classification it works, how the clustering it works, how the regression it works.